Welcome everybody to the Principles of Reactive Programming, and today we're going to talk about monads and effects. But before we do that, there are a few disclaimers. Unfortunately, there's no type checker yet for PowerPoint, and since we will show a lot of code fragments, it might be that there are typos or bugs in the code fragments. So don't take these as gospel. All the code will be available on GitHub, and that's what you should try to use when you try to run this code. Also, when we say code fragments, we really mean code fragments. So we can leave out a lot of declarations to focus on the essence. Again, the running code is on GitHub. We're using a particular version of RX Scala, 0.23 or higher. And notice that the Scala names can be different from the RX Java names. So if you look at the RX Java documentation, and in particular at the marble diagrams, sometimes the names might change. And the reason is that we wanted to make the library feel natural for Scala programmers. And the last thing, the last disclaimer, is that when I say monad, I do fast and loose reasoning. In particular, I don't care about the monad laws. So unlike a real monad where you make sure that the monad laws hold, I just mean it's a type that has a constructor and a flat map. So with those out of the way, let's get started. And what we're going to do in this first set of lectures is we're going to talk about the 4 essential effects in programming. And the 4 essential effects in programming are, in this table here, is the one that we're all familiar with, is synchronous computations that return a single value. Then we have asynchronous computations that return a single value, so that's the first column. And then we will move on to synchronous computations that return many values and asynchronous computations that return many values. But first we're going to focus on the leftmost quadrant there, synchronous computations that return one value. And this is the kind of effect that we're all familiar with, and this is the effect that's implicit in most of our programming language. So let's look at some code here. And what we're going to do is we're going to program a super simple adventure game. So here you see the trade adventure, and what you can do when you're running this adventure game, you can collect coins, and that returns a list of coins. And once you have a list of coins, you can buy treasure. That's great. So let's write a little script for our game. So we first call the constructor. There's also an object adventure that contains the constructor. Then we collect some coins, and then hopefully we collect a lot of coins so we can buy some treasure. Now this program looks very innocent, but it's really not as innocent as you think. Because as in any video game, actions may fail. For example, while you're trying to collect coins, you can be eaten by a monster, and then the game over exception is thrown, and you won't receive a list of gold. Now, if you look at that script there, it doesn't show anywhere that anything can go wrong. And even if you have successfully collected all your coins without any exceptions, you can still get an exception when you're trying to buy coins, because maybe you didn't collect enough coins, and oops, an exception is thrown. So the problem is that when we look at the signatures of collect coins and buy treasure, is that these types don't tell us that things can go wrong. And when we look at the sequential composition of our code, it doesn't tell us what's really happening there. So you collect coins, and that call will block until collect coins has returned with no exceptions. And then we execute buy treasure, which will also block until all the treasures are bought until this function returns, and only continues if there's no exception. So what we really need to do to make the types honest is that we want to expose in the type the fact that things can go wrong. So instead of having a function from t to s, we want to have a function from t to try of s, where now in the type we can see that this function might fail. And how is this function try defined? Well, that is in the next lecture. See you in a bit.